we're going to solve this equation using the addition principle. This equation says 3 plus x equals 7, but what this really means is just 3 plus some number, put a question mark here, equals 7, and we want to figure out what that number is. Now I started out really simple so that you could guess what that missing number is. And we can just take a look at this and say, well gosh, 3 plus what equals 7? 3 plus 4 equals 7. So I can use 4 as my solution. So 4 is the solution. But these equations get more complicated, so we need some skills to be able to find those other than just guessing. So let's go back to our original example. 3 plus x equals 7. What I want to do is to get the x by itself, because if x was by itself, I would read this as x equals the number over here, and that number would be the solution. So I want to isolate the x. Well, I take a look and I see that x has a 3 that's added to it. I want to undo this addition by 3. The opposite of addition is subtraction. So I'm going to subtract that 3. When I think of this equation, I think of this as being something that's balanced. So I've got the left side of the equation, and I'm balancing that with the right side of the equation. And to keep my scale evenly balanced, whatever I do to one side of the equation, I need to do to the other side of the equation. I've subtracted 3 from the left, so I'm going to follow that by subtracting 3 from the right. Now my equation stays balanced. Okay, so let's simplify. I've got the 3 plus, but I'm going to get rid of that by subtracting. I'm left with the x. On the other side, I have 7 minus 3. 7 minus 3 is 4, and I've got the x isolated, which means I can read this as x is 4. So when I replace a 4 into my equation, so right here, or right here, I've got a little more room. If I put a 4 right there, 3 plus 4 equals 7. And replacing the x with a 4 works. So I say that x equals 4 is the solution. It works for my equation, which means it makes it true. Let's do another equation. Okay, second example. For this one, let's say that we have x minus 5 equals 11. Now again, you can probably think through this one, and I think guessing is a good place to start. So what minus 5? This says, what minus 5 equals 11? So I'll let you guess at that one. We'll see if you're right here in a second. Now again, I want to isolate the x. Here's the x. I want it all by itself, but right now I have a 5 being subtracted from it. I need to do the opposite to get rid of that 5. Since this 5 is subtracted, I'm going to do the opposite and add it. That will remove the 5 because negative 5 plus 5 is 0. But whatever I've done to the left, I need to also do to the right to keep that thing balanced. So I'll add the 5 there too. Now I simplify. So let's see, on this side, negative 5 plus 5 is 0, so that's gone, and I'm left with the x. On the right-hand side, 11 plus 5 is 16. My x is isolated, so what I'm looking at is the solution. X equals 16 is the solution. Oh, let's check it. Some of you guessed at this one already, and hopefully you guessed right. To check it, we're just going to substitute. The original equation was some number minus 5 equals 11. I've got 16 for that number, so I'm going to go ahead and substitute a 16 for the x. So it becomes 16 minus 5 equals 11. Is this true? 16 minus 5 is 11, and that does in fact equal 11. So my answer here is the 16, but I can check it by putting it back into my equation by substituting and making sure that it works, that I get 11 on both sides of the equation. Let's do one more. Okay, so for our final example, let's take, let's do x minus 2/3 equals 1/6. Now I chose this one because this is maybe one that you wouldn't just guess off the top of your head. But we know what to do. We want to isolate the x. Here it is. I see that there's a 2/3 being subtracted, so I'm going to do the opposite, and to do that I add the 2/3. Negative 2/3 plus 2/3 is 0, so that goes away. But I need to do that plus 2/3 on the other side as well. So I've accomplished my goal, which is getting the x isolated, x by itself on one side. Negative 2/3 and 2/3 is 0, so I don't need to write that, equals, but I've got a little bit of work to do with my fractions. So I've got 1/6 plus 2/3. I need a least common denominator. 6 and 3 both divide into 6, so my least common denominator is 6. I need to multiply just the second fraction to get the common denominator. The first fraction is good to go. For the second fraction, I need to multiply that by a 2/2. So my addition becomes 1/6 plus 4/6. So I simplify that and I get 5/6. Remember, this was all x. So let me clean it up. This says that x equals 5/6 is the solution. Okay, if you wanted to, there we go. X equals 5/6 is the solution. If you wanted to follow this up, you could check it by substituting. The equation said x minus 2/3. So instead of x, where I've circled it right there, I'm saying that 5/6 works. So I'm going to replace the x with the 5/6. So 5/6, that was my x. 5/6 minus 2/3 minus 2/3 should equal, we'll check it, 1/6. Okay, I've got common denominators here. There's 6's, but I do not have a common denominator for the 2/3. We already found a common denominator for 2/3. 2/3 is equivalent to 4/6. So as I keep going, I'm going to take that 5/6 minus 2/3 is the same as 4/6. So I get 5 minus 4/6, which does equal 1/6. So is my answer minus 2/3 equal to 1/6? Yeah, it is. 5/6 minus 2/3 does equal 1/6. So we were able to check our answer, so we would now state that 5/6 is the solution.